Hi folks, welcome back. So discussing regression, assumption tests and diagnostics. So in the previous video I fitted a multiple regression model to some data and we looked at the assumption of normality of residuals and how you can assess that using plots and a statistical test. So as a quick recap, the data, I used the MT-CARS data set. We used MPG as our DV, weight and displacement as the IVs, and we found that weight was a significant predictor of displacement. So in this video, following on, we're still talking about regression diagnostics, but what I'm going to look at in this particular video is the assumption of linearity. So what we're going to do here is use some plots to assess if there's a linear relationship, so a straight line relationship between the DV, miles per gallon, and each of our IVs, weight and displacement. So to do this, we'll create some scatter plots using matplotlib for visual inspection. So I'm create two scatter plots, plotting each independent variable against the DV separately. And I'm going to do that. I'm basically going to create a figure with two axes on it, and then plt.subplots. I'm asking for two columns, so they'll be next to each other, one row and two columns essentially. And axis 1, I'm asking for a scatter plot. I'm going to plot weight against MPG. So weight's our x variable, MPG's our y variable, x-axis and y-axis variable, and we'll put the title weight above that one. Axis 2, we're going to ask for a scatter plot again. This time we're going to plot displacement as our x-axis variable and MPG as our y-axis variable, MPG being our dependent variable. We'll give that a title displacement. If I do a plt.show and we run that, you can see we've got these two scatter plots, two basic scatter plots. So each of them shows a single IV, independent variable, plotted along the x-axis against scores on DV miles per gallon, plotted along the y-axis. So although they're not perfect, there seems to be a fairly linear relationship between our IVs and the DV. So as scores on each IV increase, the MPV, miles per gallon values get lower. So we have this kind of general linear trend of decreasing miles per gallon as weight and displacement both increase. So visually we've had a look at this, but we can also conduct a statistical test to assess this for our particular model. So one such test for this to test for linearity is known as the Harvey-Collier test, or Harvey-Collier, depends how you want to pronounce it, I guess. So this test assesses whether linearity of the parameters in our overall model is violated. So the test does not assess the independent variables separately as we've done in those scatter plots above. What the Harvey-Collier test performs is a t-test with degrees of freedom equal to our model parameters on the recursive residuals. So the recursive residuals are linear transformations of ordinary residuals, and they're independently and identically distributed. Okay, so if the true relationship between the independent variables and the DV in our model is not linear, then the mean of the recursive residuals will differ from 0. Okay, so we'll get a mean value different from 0. And as with other statistical tests of assumptions, the null hypothesis for this test is that the relationship is linear, and if we find we get a significant result, so a p-value less than 0.05, let's say, then we have to reject the null hypothesis, and it's likely the assumption of linearity has not been met for our variables. Okay, so we can perform the Harvey-Collier test using stats models. It's another method within stats models that's pretty useful. And I'm going to do it here similar to when we did the residual normality residuals test. So I'm going to create a list called labels2, and I'm going to put two labels past the strings essentially. One saying t value, one saying p value. And then we're going to conduct in the second line the Harvey-Collier test. So I'm saving it as an object called hc_test. And to run the actual test, we're just going sms.linear_Harvey_Collier, and we're passing in the object res, which you will hopefully remember from the previous video is the results it's the results of our fitted regression model. Okay, so I'm just going to pass that in, and then I'm using that lzip function, and I'm basically passing it two parameters, labels 2, so it's going to print out these two things, and our Harvey-Collier test. So it's going to basically, what it's going to do is zip together the t-value and print next to it the actual t-value, and then the p-value and print next to it the p-value. So let's run that and see what it looks like. And there you go. So we've got a t-value of negative 0.30, or so we can ignore the negative sign there. So 0.30, let's say. Okay, so doesn't differ too much from 0. So probably telling us we do have a reasonably linear relationship, but we've also got this p-value to help us interpret it. So 0.77. So it's not significant. The result of this Harvey-Collier test is not significant. So p is equal to 0.77, and this confirms our belief after inspecting those scatter plots that the relationship between our IVs and the DV is linear, and we've kind of safely met this assumption for fitting a regression model. Okay. All right, so that's test of linearity. In the next video, I'll go on and talk about multi-collinearity. Okay, hopefully this was helpful. Thanks for listening.